This is Mec402, robotic integration. Here we have a robotic integration proposal for the Bailieigh SW503 hydraulic ironworker. The task was to automate the Bailieigh ironworker, and this required observation of the operator to understand their movements, the method that they chose to conduct this process, and the time it took to complete this process. The product started out as an 8-foot by 1/2 inch by 3.5 inch sheet of steel. These were fed into the ironworker to make the product more manageable and easier to work with and get it into the size desired by the manufacturer. This was then sent to a hole punch and was moved by a pallet jack, and this removed the three holes from the square piece of steel. This was then transported by a pallet jack again to the corner hole punch that removes the corner and creates the final product, which is an angle bracket, and it's a common product sold by our customer. This shows the current layout of the manual process. We see that we get 540 parts in an 8-hour shift, 5-day week, so a normal business week. And we can see that the value time, added time here, is 15 seconds, and the processing time in this process would be 4 minutes and 44 seconds. So this shows a little bit more in depth of the individual processes. We start with the shear process. This involves the operator taking the 8-foot long piece of steel and cutting it with the shear into the hydraulic press, and it makes a more manageable size. The cycle time of the machine at this point, 3 seconds, so that's how long it takes for the machine to actuate and retract. The processing time per part for individual part for this process is 88 seconds. The value added time per part is 3 seconds. This is a single directional process, and the weight of the steel sheet at this point is 47.5 pounds, which can cause some problems for an operator, depending. At this point, the operator is also exerting a lot of force to get this into the machine. They do have the help of a rolling system or a conveyor belt, but that's about all. The next process is the hole press process. This process removes 3 holes from the piece of steel by placing the part into the fixture and removing the hole. This product is then rotated 90 degrees and another hole is removed. This is repeated to complete 3 different rotations, which produces 3 holes. This still has a cycle time of 3 seconds. This has a processing time of 88 seconds again, and the value added time per part is 9 seconds. And this is the longest out of the manual process because it takes 3 actuations. And it also does require a fixture plate to line up the holes. And the final process is the corner process, the corner press process. This process removes a corner out of the piece by the operator placing it into a fixture and then actuating the hydraulic press to remove this corner. And this completes the angle bracket product. This still has a 3-second cycle time. It has a processing time per part of 88 seconds. And the value added time per part is 3 seconds again. And it does also require a fixture plate. But it does not require 3 actuations, only 1. So we can look at a manual time loss breakdown here. We can compare our value added time and our processing time per part. And we can see that our value added time is 15 seconds in total. And then our processing time is 264 seconds total. The subtraction or the sum of these two is 249 seconds. So that shows that we are losing 249 seconds compared to the value added time. And that's okay. We also have our total value added time and our total processing time. And the sum of those two is 131,900 seconds or 2,198 minutes a week, which shows just a little bit more of a dramatic add up of time over the week. We also have now our automated layout. This robotic cell also has the capacity to produce the minimum of 540 parts. However, it's in a time of 4 hours and 12 minutes. The value added time per part in this process is 15 seconds. And the total processing time per part is 28 seconds. This shows the first start of our automated process, which starts with the hole press. This would also do a same 3-hole pattern. However, we would be feeding the part in with a bar feeder. And this would cut out the 3 holes in a pattern in a single motion. This would produce a cycle time of 3 seconds, a processing time per part of 16 seconds, and a value added time per part of 9 seconds. This will also require a fixture plate at the end to hold the piece of steel before transporting it once it identifies that the piece is present to the next station. Then we come to the shear process. This process would involve a conveyor belt and 2 induction sensors that allow the hydraulic shear to cut 3.5-inch pieces. And this happens very rapidly, and then they're transported with a chute to the next process. This would also have a cycle time of 3 seconds, a processing time per part of 6 seconds, a value added time per part of 3 seconds, and it's also single directional process. However, we have a 0-pound weight on an operator because we do not have an operator present here. The corner press process is after the pieces fall down the chute, and this process involves the Omron TM Flow collaborative robot. This robot uses its vision system and vacuum to collect the pieces of steel and feeds them into the corner punch 1 part at a time. And then they're placed onto a conveyor belt after producing the part, and then that takes them to packaging or further processing. We have a cycle time of 3 seconds, a processing time per part of 6 seconds, and a value added time per part of 3 seconds. And there's also a fixture plate needed here for the robot to feed the part into the hole punch or the corner punch. We show that we have a value added time of 15 seconds here, which is actually the same as the last one. However, we have a lower processing time of 28 seconds. This shows that there's a time loss of 13 seconds between our value added time and our processing time per part. If we look at our total value added time and our total processing time, we have a total value added time of 8,100 seconds and a total processing time of 15,120 seconds. And if we subtract the processing time and the value added time, we have 7,020 seconds, or a total of 117 minutes a week of loss. So if we look at the total time loss comparison, the difference between the manual process and the automated process is a difference of 2,081 minutes. So we're looking at a gain of 2,081 minutes a week here, or for 500 parts. And then if we look at the productivity of those two, we see that we have a total processing time of 15,120 seconds and a total processing time of 144,000 seconds. This shows a total time loss difference and a increase of 952% productivity. Now, if we take a look at the bill of materials that would be required to complete this concept, we would need an end effector. That would be $2,370. Pneumatic hoses, $1,595. Compressor, $279. Siemens S7 1200 PLC, $308. An induction sensor times 4, that's $100. Hydraulic pump, that's $315.99. We need 4 hydraulic hoses. Those are $11.57 a piece. We need 14 gauge wiring, 100 feet of it, which would be $18.30. And we need the Omron TM Flow robotic arm. That would be $39,000, which brings us to a grand total of $39,992.51. Here is a side-by-side comparison of the manual process and the automated process. We have the weekly 540 parts for each. Now if we take a comparison of the first process versus the automated process, we can see that this was the second position. This is the first position now. The input on this side is an 8 foot by 1/2 inch by 3.5 inch steel sheet. This side is 3.5 inch by 1/2 inch by 3.5 inch steel square. The output's a 3.5 inch by 1/2 inch by 3.5 inch steel square with 3 holes removed. This is the 8 foot by 1/2 inch by 3.5 inch steel sheet with 3 holes removed per every 3.5 inches. Our cycle time is 3 seconds, value added time 9 seconds, total value added time 4,860 seconds, per part processing time 88 seconds, total processing time 48,000 seconds. Our timing on this side is 3 seconds, value added time 9 seconds, total value added time 4,860 seconds, per part processing time 16 seconds, total processing time 8,640 seconds. On this side, we have the shear as the first process. On this side, we have it as the second. We put in the 8 foot side on this one, and we have actually the same product going in, except this one has holes, this one does not, but it's still an 8 foot by 1/2 inch by 3.5 inch steel sheet with holes, no holes. Our output is both a 3.5 inch by 1/2 inch by 3.5 inch steel sheet with no holes removed, 3.5 inch by 1/2 inch by 3.5 inch steel sheet with 3 holes removed. Cycle time is 3 seconds, value added time 3 seconds, value added time is 1,620 seconds, per part processing time is 6 seconds, total processing time is 3,240 seconds. On this time, we have 3 seconds for our cycle time, value added time 3 seconds, total value added time 1,620 seconds, per part processing time 88 seconds, and total processing time 48,000 seconds. For this side, we have our position and task, which is third. This is also the third, and they're actually doing a very similar process here. 3.5 inch by 1/2 inch by 3.5 inch steel square with 3 holes. That's the same on both, and out comes the same 3.5 by 1/2 inch by 3.5 inch steel square with 3 holes removed and a 1/4 punch, creating an angle bracket. That's the same for both. Our cycle time for this side is 3 seconds, per part value added time is 3 seconds, total value added time 1,620 seconds, per part processing time is 88 seconds, total processing time is 48,000 seconds. On this side, we have 3 seconds for our cycle time, per part value added time is 3 seconds, total value added time is 1,620 seconds, and our per part processing time is 6 seconds. Our total processing time is 3,240 seconds. So if we look at the KPI breakdown of this process, the current manual process produces a value added time per part of 15 seconds. The automated part produces a value added time per part of also 15 seconds. The manual process is producing a processing time per part of 4 minutes and 44 seconds. The automated process would generate a shorter processing time per part of 28 seconds. The complete processing time of 540 parts is 459,000 seconds, which is around 5 full business days. The automated process allows for a brief total processing time of 4 hours and 12 minutes within 1 day. And when we look at the final product, we're maintaining the original manufacturer design and quality. Everything's still the same. We're reducing the per part processing time by 4 minutes and 14 seconds. We're able to produce 540 products in 4 hours and 14 minutes compared to the current process, which will take 37.5 hours. In addition to this, we're also preventing 127 hours a week of operator repetitive motion injuries that could be present, and it provides room for scalability of yields up to 10 times that of the current process. So if we once again look at the automated process, this is what we see. And that's everything. Thank you for watching.